Thank
Hello.
you. Thank you for the invite. It's great to be here and share a little bit of our work with everyone. Um, so I have already been introduced, and for the next 30 minutes or so, I will tell you a little bit about how we at Dime approach research transparency and reproducibility. And hopefully by the end of this talk, uh, you'll understand a little bit what both my position means and what my team does. And also, I hope to convince you that what we do is important, but let's get to the end of it and see how convinced everyone is. So, like most empirical and scientific work, there is growing scrutiny around the evidence that we, as impact evaluation researchers and practitioners, create. And over the next few slides, I'm going to try to convince you that given the high stakes of the research we do, this is actually a good thing. This conference, well, a lot has been said about impact evaluation of development interventions. So you probably know that empirical research, like impact evaluation, is by now the norm in the development economics field. In fact, in 2015, around 95% of development papers published in 80 of the most cited economic journals were empirical. And the findings from the research that we do affect people's lives. Since this is an impact evaluation conference, I will assume that most of you are already convinced that evidence-informed policy is desirable, and if you are not, I will let Maria do the hard work of the convincing. And for my purposes, what I want you to focus on is the fact that influencing policy increases the stakes of creating accurate and credible evidence. Accuracy matters because results that are inaccurate can lead to inefficient or even harmful policies being adopted. But even if the results are accurate, they will only inform policy to the extent that policymakers trust the results that we are presenting. So the economic research community has been taking a few steps towards making economics a more open science. And the AEA's data and code policy is probably the most relevant and well-known policy in this direction. But another important example is also the Journal of Development Economics pre-results review, which we'll talk a little bit more about soon. So we will discuss in this presentation some standards and practices that are available to increase transparency, reproducibility, and credibility of empirical development research. And I will also talk about the constraints to adoption of these practices and how we at Dime have been dealing with these constraints. So when we think about economic research and scientific research in general, what can go wrong? In theory, a study is judged by the soundness of its methods and the quality of the data that's used. So peer review exists to prevent that bad science from being disseminated. However, the same mechanism also creates a system of incentives where the success and recognition of a researcher depends on their publication record. And given that certain results have higher chances of being published, this creates a system of incentives that can lead to a biased body of evidence, as we'll see. So the most well-known example of this is the fact that it is harder to publish no results. But economics journals also tend to prioritize novel results or counterintuitive findings, a result that debunk previously existing evidence. And this is likely due to a combination of different factors, such as referee and editor preferences, but also to practices that we popularly call cherry picking, p-hacking, and also the file drawer problem. All of these issues involve the fact that researchers foresee that less interesting or no results will not be published, and either don't submit these results at all, or try to take advantage of their the research flexibility and look for the most interesting and significant results to submit. So for those of you who have who are watching online or who have a cell phone at hand, I recommend a very nice example of what specification searching means, and you can find that by Googling XKCD. This is a comic blog, and Jelly Bean and acne. So all of this in the same Google search, and you see some very interesting illustration of how specification searching can arise and how that's read into the media, and you know, how non-researchers may interpret this. But all these factors being combined, as I said, may create a biased body of research evidence. And there are two things to note here. The first one is that this can occur even if all the research practices involved are like the best. So even if you're using sound methods and trustworthy data, and there's no bad faith involved. And the second one is that scientific knowledge is built on finding results consistently. That's how we establish something as scientific knowledge. So, for example, something that could happen in the context of no results not being published is that researchers are focusing their time and effort on a subject where there is little evidence, but actually there's more research on this subject. It just has never been published because no results were found. Or even worse, policymakers may be insisting on a policy because no one ever published evidence that it does not work, while in fact, this evidence is all sitting in a drawer. But I want to make it very clear here that what I'm saying is not that you should not trust science. So please don't get out of this talk and say, well, this girl just was talking here and saying all this nonsense about how we cannot use evidence-informed policy. That's absolutely not the point I'm trying to make. What I'm trying to say is that there are steps that we can take to make sure that our research is even more credible and more transparent. And there's a lot of existing ways that are already popular to address these issues. So one way to do this, and specifically a way to address the problem of biased publications, is to document specific research design components, ideally before even carrying out any analysis or exploring the data. And there are a few popular methods to do so, the most simple of them being study registration. So this basically means that you will announce that you're conducting a study, and whether this study is published or not, there is a record that it happened. Researchers can also choose to register not only the fact that they are doing this study, but also the specific design and the methods that they're going to use to answer particular questions. So this is particularly useful when you're working with a data set and you foresee that people may say that the results that you are getting are people could interpret them as specification searching. So basically you are saying, look, I'm not just trying a million different things here and seeing what sticks. This was actually the plan. This is the heterogeneity analysis that I was planning to do from the beginning. I'm not only reporting this because that's where I found significant results. But this approach can also be taken to the very next level with registered reports. And this basically means submitting your whole research design for review in such a way that the journal can accept what you are doing based only on your methods and not on the results that you found, because you have no results yet. And so the journal commits to publishing the outcome independently of the results found. However, even if you have, pre-specified your design and you are following the design as such, as a matter of principle, no one should just have to trust you and believe that, yes, this is indeed what you implemented. But rather, research consumers, be them other researchers or policymakers or practitioners, should be able to judge for themselves whether the research was done well and whether the decision-making process involved at all steps was sound. So if the research is well structured and all of the relevant documentation is shared and made available, the reader is empowered to do that. So that means exposing the research processes and documentation like variable dictionaries, questionnaires used, and even field protocols used during data collection. Now, one thing that is particularly relevant in the field of development economics is that unlike disciplines where data is more standardized or the use of administrative data is more prevalent, many of the data sets that we use are purpose-built. So they have never been observed by anyone else in the past and possibly cannot be recollected in the future. So for all purposes, making this data open as much as possible while maintaining the privacy of the research subjects is not only a good practice, but also a public good that you're creating for the rest of the research community. And many journals require now a data citation. So if you're using a novel data set that you created, you are required to publish this data set somewhere. And this also has the plus side of generating another source of citations. But going back to the point that no one should have to just trust you, no one in the same sense should have to try to guess how you created a constructed variable or what controls are included in your regression or whether you clustered your standard errors as you said you did in the paper. They should ideally also not have to bother you and ask you, so what would happen if you would try this slightly different? It is, in fact, an increasingly common practice in PhD courses to replicate paper during courses, and then many times, people can simply not understand how researchers and authors got to a particular data set or a particular result. So making sure that the code and data are also available is an important step towards open research. Not only is it good practice to reproduce results, it is also very easy to make mistakes in code. And if no one else is taking a look at the code that was used for a particular paper, it is very likely, and in fact it does happen a lot, that mistakes go undiscovered for a very long time. And in many areas of science, replication studies are very common. So basically you do exactly the same experiment and in a different lab. However, in economics, there are obvious limitations to doing so, given that the conditions for a study cannot be easily replicated, and in fact, this is many times impossible. So we settle for reproducibility, which means can we use the same data and the same code to get to the same result? So this is already, a requirement that's not as stringent. And in fact, a lot of journals now require authors to make reproducibility packages available, so that you need to at least publish your final analysis data set and the code that you used with it. And not only that, some journals also, will verify that they can also achieve the same results with exactly the same data and code. So researchers who are being trained right now are much more likely to be exposed to the kind of discussion that I have just summarized. And I'm sure for most of the audience watching this talk, this is not new. However, what is observed is that actually the way research is conducted is largely cultural and path dependent. So it also depends a lot of what has happened in the past and how past researchers were trained. So right now, open science is not yet the norm. So the study from Sebastian Gagliani, Paul Gertler, and Mauricio Romero that was published in Science, for example, found that less than 1 in 7 of the more than 200 papers that they analyzed actually made the material available so that other people could reproduce the results. Around the time, the AEA released their new data and code availability policy, we at Time were conducting a conference about research transparency, reproducibility, and credibility with a lot of other organizations. So we conducted a short survey of researchers and practitioners about how they implement and view open science, so we could get a little bit of understanding about why open science is not yet the norm. And the average principal investigator said that in a scale from 1 to 5, their level of preparedness to make data and code publicly available and reviewed before publication was 3.5. So there's a lot of variability here, as you can see, but most people say they're not completely prepared to deal with this policy. When we asked what they still had to work on and what practices they could benefit the most, most of the principal investigators said that they really did not have knowledge or training or resources on new skills such as coding. And I personally interpret this as being due to the fact that most of the other practices that we have mentioned basically come from a different habit. So from taking an extra step as you're doing your research. So this is basically a cultural change and not, actually developing a new skill. And at the same time, the most cited reason for people to not, of why people have not developed these skills is that there is a high cost of entry. So that could be in terms of time, that could be in terms of monetary cost, or that could be in terms of, just getting your whole team to agree on a practice. And the last finding that we got that I want to share with you is that we at Time adopt these practices, this open science practices, not more than other researchers, but not only that, we also reported having more access to resources. And what I want to share with you is basically how we got there. So what we did to get over this constraints to adopting practices for open science. So Time's strategy was to create standards that all researchers are expected to follow, to disseminate these standards among the researchers, and also create incentives so that researchers would actually implement them. But not only that, Time also offered support to adoption so as to lower this high entry cost that a lot of researchers mentioned. And the form that the support takes is basically Time Analytics. So that's the team that both Maria and I are a part of. So we are now around, I believe we're 7 people that basically work across the whole giant portfolio to support the adoption of best practices and identify areas that need improvement. So basically what we do is we take advantage of the scope and scale of time. There are a lot of projects around, I want to say 220 projects right now, give or take. So a lot of teams that are finding solutions, implementing them, and improving them. And we work with these teams to share the knowledge and use this knowledge to improve the quality of data collection, of the data use, of the research conducted, and improve the transparency of our projects, but also to create public goods and trainings so that these resources are available for other teams. So that's basically creating a virtuous cycle that kind of feeds on itself. But how are these standards actually implemented in practice? Well, this is a lot of work actually, but I want to give you a few examples from the items that I mentioned before. So one of the things that we do is a push button reproducibility check. So since 2018, someone in DIME Analytics actually takes the reproducibility packages from all the working papers and checks that we can run this code and recreate exactly the same results. So by the end of 2019, about 64% of the papers passed this check at the very first try, and only 9% of them needed major revisions. This is compared to 50% of the papers reviewed in 2018 actually, needing a lot of work to improve their reproducibility. And if you look at some of the papers I mentioned earlier, this is actually a lot better than some of the top journals in economics. But this is actually, if you stop to think about it, not such a high standard, because just making sure that your code runs on exactly the same data and recreates the same results does not mean that it is correctly coded, or that your research is well specified, or that the regressions that you're running are actually coherent with the research design. What this means is basically that once there is an expectation that the code will be read and tested, makes researchers more likely to review their own code and catch their own mistakes. But also that researchers are learning from these mistakes. So since most of the errors are the same, and I can talk for a very long time about what kind of issues we're catching when we do this kind of code review, if we catch these mistakes once and show to a researcher, this is what's happening in your code, and this is why your result is not replicating, then this issue can be avoided in future submissions and improve the reproducibility of the packages submitted over time. But again, as I mentioned, this does not mean that the code is actually doing what the research design specified. So what we did after we implemented the reproducibility check is that actually this year we started to implement peer code review process that is done while a project is ongoing. So every quarter, all of the research assistants in our team get together, share, read, and test each other's codes. And why do we go through all this trouble? I mean, this is a lot of work. This is getting, a whole day of work from 20 research assistants once every quarter, and everyone will sit down and read other people's code that they are not familiar with. And the reason why we actually go through the trouble of doing this is because no matter how good your methods or how well designed your experiment is, the evidence is only as good as the data behind it. And there are, as I mentioned before, plenty of mistakes that can be made between establishing a design and generating the final results. And any of these mistakes could potentially compromise the conclusions that are being reached at the end of the study. So the point of doing this peer code review exercise is to create an incentive to adopt best practices on coding, but also, exercise the muscle of open research through the whole research process. And this is creating a culture of sharing code for other people to read, like I'm sure that everyone watching this talk does with their text. So when you write a paper, you share it with your colleagues for review, or even emails. Sometimes you ask for someone else to take a look. So why not do the same with code? And I want to show you quickly just 3 graphs of the results that we have gotten from the second to last quarter of code review, because I think this is informative, given that this was a cohort of research assistants that had been working for DIME for about a year on average and had received the whole training that we do. So 68% of the code that was reviewed was reproducible. So meaning that at the very first try, the reviewer was able to recreate all the outputs exactly as originally submitted. And 6% of the code actually needed a few tweaks. So basically what this means is that at the end of one day of code review, all the results were reproduced. So this is consistent with what we see on the reproducibility checks, since it's easy enough to make sure that your results are reproducing. It's easy once you know that someone is going to look at it to make sure that this is happening before you submit your paper or your code. So this one is a check. Now, making sure that code can be transferred across machines is a lot more difficult. And in fact, when we look at the number of reviewers that are able to run the whole code, we see that 30% of the projects needed adjustments, and 4% of them were just not able to fix whatever bug was causing the code to not run completely. So at the end of one day, you still had 4% of projects that we couldn't figure out. And the place where there's actually the most room for improvement, and that's something that we are currently working on, is whether the person reviewing your code can actually understand what it was doing. So like, can I go line by line and understand what's going on? So basically, the hardest part is actually writing code that is as readable as the paper that explains the same results that this code is finding. And this is important for research transparency because, yes, being able to reproduce results is important, but can the research consumer also tell, if this is actually what's being described in the paper? Right now, about 30% of the ongoing projects that we got did not pass that far. So switching gears a little bit, from research reproducibility to research transparency. Another thing that we do at time is that we require all projects to have their studies registered before they can receive funding. So this is the least stringent form of a pre-commitment of the three forms that we discussed before. And the registries that we typically use are RIDE and the American Economic Association RCT registry. I also added a link here to the JD pre-registered reports, even though we don't require them, because that is, well, encouraged. Oh, yeah. So here it is, the link. That's also so everyone can, who has the presentation, can later click on that and see the instructions for authors. Now, another thing that we require is that projects publish their de-identified data on the World Bank's data platform. And there's I was just seeing actually a tweet from Lars Vilshuber, the AEA data editor, that was saying just like, yes, it is possible to do open science and still respect the privacy of your subjects. And, you know, there are a lot of different ways to do this, but some of the most simple ones are just restricting access so that researchers need to ask to use the data set, or even embargoing variables. So yes, you can access the data, but you cannot access certain variables that are sensitive. So basically, if you look to all of this from a bird's view, what we try to do at time is approach the whole workflow of research. So we have a lab structure where there are specialized skills inside a research team. So there are people, obviously, that so everyone is doing research, but there are principal investigators who actually focus on the design and, you know, writing papers. But there's also people who really know their code. And we make sure that whenever a new research assistant is onboarded, they have this view of the whole workflow, and that they are trained on both the principles of the research standards that we implement, but also on the practical side and how these actually translate to our day-to-day work. And when you start your work with this whole research workflow in your mind, you can also see how, you know, adopting best practices now will save you time and probably gain you some credibility in the future. Now, I want to, you know, emphasize that we have been developing these new policies for years, and these are incremental steps, and we probably add about one new practice at the department level per year when, you know, this has been tested and we know that this can be scaled up. But I think what matters for everyone who's seeing this is that we also make these materials available and, you know, tools and trainings available for the larger research community. So here is a quick list of public goods that we provide. We have a book that's basically a data handbook for research assistants and field staff. We have a wiki where there's a lot of resources to all things impact evaluation. We have 2 code repositories for data visualization, which is something I'm very much interested in, and I really think that should not be so hard to do. So we have code and examples of how to display results in both Stata and R. And we also create software packages in Stata to do a lot of these tasks that are repetitive and that take a lot of our time, that we would be better off using to do, more research. So all these manual steps that are involved in data cleaning or data management, we try to automate them as much as possible and make it so every researcher can also use this. And for a quick list of the items that I mentioned before, that yes, we do have, DIME Analytics supporting the teams at DIME very closely, but we also have, for exactly the same standards, checklists available that everyone can use. And, doing code review, for example, is something that you don't need DIME Analytics to organize around for. It's also just a cultural change in terms of asking your peers to also review your work. So I am, I said 30 minutes. It's, I guess, 32, 33. But this is all that I wanted to share with you today. And I hope you are convinced of the relevance of open science to the work that we do, but also that every investment you make in documentation and transparency up front protects your project down the line, particularly as these standards continue to tighten, not only for the development research community, but for the science community in general. And I also hope I have convinced you that no one needs to go to scientific hell. Making open science and open research is a challenge that we're all facing together, and it is a work in progress. But most importantly, I hope that you will see for yourselves that this initial investment is not necessarily as high, and the task of making open science is not as daunting as it may seem. And just to, kick this effort off, there's a list of resources here for anyone who is not familiar with them yet. And this presentation is also available at the Open Science Framework at the link below. And here are the references to all the studies talking about open science and reproducibility in economics. Thank you.
Thank you, Luiza, for a very informative presentation. I'm In-Book Ree from the KDI school, and I thought it'd be useful to maybe just pause for a little bit, and if you would entertain a couple questions before we move on to the next presentation, just in a fear that, after the next presentation, people might forget some of the questions that they may have had. So I'd like to invite the people from the floor as well as anyone online, if they have any questions if it's okay with you, Luiza, to maybe entertain a couple questions now, and then maybe after the second presentation, we can circle back and see if we can have further discussions. But as I sort of allow people to think about their questions a little bit, I just wanted to provide a very strong endorsement for all the excellent resources that DIME provides. I actually had directed my students to go and check out your visualization libraries during my class. And I think those are really excellent resources. Again, although as someone who studies political science, I wouldn't necessarily say that these are econ visualizations, rather just generally useful for sciences. One question that, if I can put myself on the queue, one question that I had, or rather more of a sort of just wanted to listen to your thoughts, was especially about registration. So personally, I'm all for reproducibility, trying to make sure that we can be transparent in our research. But at the same time, I've been a little bit hesitant myself as a researcher, thinking about what to conceptually think about registration, especially because, often of course, our research should be sort of driven by theory and expectation and up to the best standards of science, so that we can set up all the things and then do the test and report it back as transparent as possible. But sometimes, our studies are not necessarily confirmatory, but rather exploratory in nature, right? So we sometimes have data, we don't necessarily know what we're really looking for, and in the process of looking at the data, sometimes we come up with theories, sometimes we come up with ideas, and I've even seen someone express this in a way like, sometimes going through your data is almost like doing field work in your data. You don't necessarily know what you're looking for, but in the process of engaging with your data, you can actually come up with good hypotheses, research design, and so on. So, but that does not seem to go too well with this idea that we are setting up how we're going to do the studies ex ante. But I don't know, since you are both very closely involved in academic as well as policy research, just wanted to hear a little bit of your perspective on these kind of matters.
Yes, absolutely. I think this is actually a concern that is quite common. And basically, I think, we should not see pre-registration as golden handcuffs. Basically, we should see pre-registration as a way to protect the research that we are doing. So this does not mean that exploratory research does not have value, and this does not mean that exploratory research should not be published. Absolutely. And even, registered reports do not mean that from the same data you cannot then find exploratory analysis that will be very useful. But rather, if you know ex ante what you want to look for, having this pre-registration of your analysis is a way to protect your results. So this basically just means that yes, the journals will treat differently analysis that were pre-registered or not, but that does not mean that analyses that were not pre-registered will not be published, or that they do not have value. But I think, as I mentioned earlier, basically, this is a way to say, look, I'm not p-hacking here. This is the heterogeneity analysis that I was interested in. But if you find some results that you think are interesting and you want to publish that, that's obviously super valid and just as important. So I think we should see pre-analysis plan more as a way to add value to non-exploratory work than to remove value from exploratory work.
Thank you. And let me see if I can turn to the room and if there are any questions from the floor. And let's see. Let me give my microphone to you.
Yes, thank you very much. I enjoy your deliberations. I'm Sam Brown from KDI, a student. And I'm just a little bit curious because I believe that research transparency should be the hallmark of all research, which you have deliberated well. And I want to extend my own appreciation for the insightful presentation. I'm curious to understand the scope of the DIME standard. What is the scope cuts across all of the research methodologies? And on the other hand, were there a problem or were there issues with other research standards that DIME had for which you had to carve your own standard, or this is the first standard for researchers? That's just my own curiosity that I want to understand. Thank you.
Thank you. If you download the presentation, and I believe this will be made available on the website, it's also on the Open Science Framework website. There's a link to a repository where we list all the standards that we require our projects to comply with. And these, well, I don't have the presentation up anymore, but these involve both research ethics, so informed consent, protecting subject privacy, having learned about doing research with human subjects, to research reproducibility, data publication, research transparency, and data security. So these are the 5 pillars of our standards. And obviously, I mean, I believe, and they are all available online, and we both state what are the requirements for done projects and also link to resources for other people to and for our researchers to know how to actually implement these things in practice. And I believe basically this is just a formalization of what are the requirements that we commit to. But obviously science has its own unwritten laws. And I don't think that our standards are better or worse than the classic Mertonian rules for science. Is just a way for us to make transparent and make an open commitment to the standards that we uphold, and making it clear to all the researchers that are working with us that they need to adhere to the standards, and also that we are ready to support them in doing so.
All right, thank you very much. And I think we should proceed to the next presentation. And then towards the end, we also have some time left for further Q&As and discussions. So for those of you who are on the floor, as well as joining us from online, please maybe just jot down your questions, and maybe we can get back to those after the second presentation. And by the way, again, there are excellent resources shared by DIME on many different venues. I was just checking out their GitHub website, for example, and all the presentation materials, all the DIME standard presentations, and those are publicly available, and they seem to be a very, very useful resource. So maybe we should also post those links on our YouTube link or something, so that people can have easier access to them for those of you who are listening to this. But let's proceed with the next one, and let's see.